Now the lead code problem we are going to solve is called permutations, and we can see that this one is a medium problem and also an extremely well-like problem. The statement is quite straightforward, that we are given an integer array called nums of distinct integers, and we need to return all the possible permutations that we can make. And for good thing for us is that we can return answer in any order. So first let's try to understand this with few examples. Let's say that in the input we are only given one element, then we can only generate just one permutation. So this is what we need to return. But if we are given more than one element, let's say 1 and 2, then we can actually generate two permutations in this case. First permutation is going to be the same value as it is. In the second permutation, we are going to have the values being flipped around between 2 and 1. So these two are the permutations that we need to return. Let's take one more example. Suppose in the input we are given the values 1, 2 and 3. Then we can basically calculate that we should be able to make 6 permutations in this case. Why? Because for any particular given numbers, you can make n factorial permutation. So in this case we are given 3 elements, so 3 elements is going to be 1 multiplied by 2 multiplied by 3, as in 3 factorial. So in this case the answer is going to be 6. Now let's see that what are all these 6 elements are going to be. Well, so these are all the 6 permutations we can make. Now logically this is nothing more than a decision making element or decision making algorithm, because over here we can see that if we have to make permutation of this element, let's say that I have 3 blocks where I can fill in values. Now let's say for some reason I decide to put 3 in the first block. Then I know that I still have 2 values where I need to fill out something. But the thing is, I can only fill out between this value 1 and 2, not this value 3. So once again I can repeat the same process, and let's say randomly I decide to pick value number 1. So now for this last element I only have just one possibility, and that is to fill in this value number 2. And this, the moment it reaches to the length of this previous one, we can determine that this is one of the permutation that we can store as part of the answer. Now after storing this, we need to check that whether keeping this 3 over here at the beginning, are we leaving out or being done with all the permutations? No, there are still possibility of permutations left. Let's say that we decide to eliminate this value number 2 over here and this value number 1 over here. Now once again, keeping this 3 on this place, once again we have the option that instead of selecting 1, we can actually select 2 over here, then we will have 1 over here, and this would be a new permutation. So visually this is very simple to understand that how does this function, but the thing is implementing this is slightly tricky. So what I'm suggesting is that we actually use the same algorithm that we just saw, but we apply it using the logic and possibility and concept of backtracking. Plus on top of it, after using the backtracking, I also suggest that we use a recursive approach to recursively recall the same function with different inputs. And why am I suggesting this is because number one, we already know that we are repeating the same process. All we are doing it is that the input we are given, we are picking one value in, we are marking that particular value with one of the values, and for that, let's say that over here we have 1. So once again, now we have two possibilities. First possibility is that on this place, for the second place, we can fill in the value 2 or we can fill in the value 3. Once again, let's say if we decide to fill in value number 2, then we are only left with just one possibility for this last element, that is this value number 3. And this whole path defines one of the permutations. So this we will be able to mark as the answer, and then if we decide to go down this path, once again the values are going to be 1, 3 and 2. So this is going to be our second permutations, and once again we can mark this answer as well. So now let's say that what are the things we need to solve this problem and how we are actually going to be doing that. I just explained that we are going to be using backtracking plus recursion. So let's say that what do we need for our backtracking function? The idea is quite straightforward, that we will keep on going in one direction until we reach to the length of the given input. Once we reach to the length of the given input, we will mark that entire path as part of the one of the answers, and we would put it into our list of lists that we have created to store our answers or results. Once doing that, the idea is to once again do a backtrack, and after doing the backtrack, once again see that what is the potentially different path that we could have taken, and once again once we reach to the answer, we basically store that answer. Now there are two critical parts in this case that we will have to consider. Number one thing is that we will need to know at some point that what are the values we have already calculated and what are the values we have not calculated so far. So what I'm suggesting is that let's say you decide to put 1 over here, then I would need some sort of way for my computer to tell me that this 1 is already part of the function. So for that, I'm suggesting to use a used array, or like array named use, and the moment we add any particular value inside the current consideration for our recursive function, we are going to mark this used function as true or false. So this would be my used array of boolean values, and currently I would mark that this is true, which means I'm currently considering 1. Then once again, let's say that now I know that through my used array I only have 2 more possibilities left because this 1 has already been filled. So for the next element, I'm going to consider this value number 2, and once again I'm going to mark this value 2 as being used as one of the decisions. After doing that, once again I'm going to mark this value 3, and then I'm going to mark this 3 as being used. But the thing is, because I reached to the end of the list, so the moment I reach to the end of the list, I can mark this answer 1, 2 and 3. And after marking this answer, I can actually go back, and I can go back in time with my recursive function and say that over here, instead of using 2, now I have decided to take another path where I'm going to be considering 3 as part of the input. And in order to do this one, I will need to constantly update this used array. That is number one thing. Second thing is, in order to calculate this path, I will also need to have a current array or array list to store this path as well, that these are the values we are currently iterating. And the moment we identify that we have reached a new answer, then for the next iteration of the recursive call, I simply need to regenerate the entirely new array. So I know my solution might confuse you a bit, but let me just give you this with like using 2 examples. So let's first quickly take the example of simple 1 and 2 values. Okay, the logic is that we are going to have a recursive function that is going to store. So for the recursive function, I did not explain, but basically for the recursive function, we need 2 items. So we need a base case, and we need that what is going to be our recursive call. Base case is quite straightforward, that the moment we identify that our given current n, or the current length of the given input is equal to the original n of nums, then we have found the correct path. In this case, we would mark the current path inside the answer, and after marking that, we would basically return. So this is going to be our base case. Now for our recursive function, the idea is quite straightforward, that we are going to pick one element right now, and through that one element we are going to be marking the used array for that particular element to be true. And then we are going to call the recursive function once again with the remaining portion, because we still haven't identified all the values. Once we identify all the possibilities and we receive an answer back, then we are going to eliminate the last element we had inside our recursive function to be turned out to be false, and keep on repeating that in order to calculate other possibilities. So let's first see for this example. The idea is that first of all, over here I have 2 possibility. Let's say I mark number 1 element as being used, and I have a current list where I'm going to store that what is the current path I'm taking. Okay, I took 1. Now I'm once again going to call for the next element. So now I call for the next element, that is obvious choice 2. So I mark 2, and now I know that my length of this current has reached to the n. So I'm going to mark this as part of the answer 1 and 2. After doing this, once again I'm going to do a backtrack call. During the backtrack call, I'm going to mark this 1 as not being used and 2 as not being used, and then I'm going to be iterating over this given input in this fashion. So I already took care of this element, and now I'm going to start taking care of this element. So now I have my 2 as being used. Now I have my new current instance being created where I'm starting the path from 2, and I'm going to go down to the next path. So I only have one possibility, that is to add value number 1. So I'm going to add value number 1 over here, mark 1 as being used, and because this n is correct, so once again mark the another answer as 2 1, and now I have my answer that I was looking for. So after this, I realized that in my existing loop, I already be done through all the elements inside the given input. So which means now whatever I have in the answer, I can simply return that. So now if you want, you can directly go to the coding approach if you already understood what I meant. If you didn't understood, then let me also do the same iteration for this path as well, and once again repeat the same procedure. So logic is we are going to be iterating over every single element one by one. That is number one thing. Next thing is we are going to have our current list or the current values we are iterating over, and we are going to have our used array where we are going to be storing that which are the elements we have already used so far in the current iteration, and we are going to be updating the values one by one. So let's say that in the current path I add value number 1, so I'm starting the path from value number 1. After 1 I decide to add value number 2 as an input, so once again I do that, and after this 2 I add value number 3. So the moment I add value number 3, my length is equivalent to so I'm going to store the answer 1 2 3. After storing this, now once again I do a recursive call. So I basically break out, so which means I will have to remove the last element I added. Still keeping 1, I still have one more possibility that I haven't tested. So once again I'm going to mark 3 as being visited. So now I'm going to take one more path, and by the way this is going to be a new instance where currently the nodes I have visited are 1 and 3, and next time I'm going to be visiting the value 2 because that element is left over here. So once again I'm going to be marking 2, and I'm going to have one more possibility 1 3 and 2. Once again now I do a backtrack. So backtracking would make sure that I took care of 3 over here, I took care of 2 over here, and all of these things are done. So now my used array is being backtracked to all the way to the beginning. So now once again I'm going to repeating the same process, but now this time with value number 2, and keep on doing this recursively until we reach to this very last element 3, where we have all of the 6 possibilities calculated, and this is the whole solution. So now let's quickly see the coding solution, and that would make much more sense. Now first thing we are going to do is that we are going to create a new array list which is going to store our results. So now you can see that this one is an array list that stores different array list inside. Then we are going to initialize our used boolean array in order to keep track of that what are the current elements we have already used. And then we are going to have a helper method called backtrack, where as an input we are providing our result that we have calculated so far. Then we are going to have a new instance of an array list where we are going to be storing the current elements we are iterating over. Next we are going to be passing in the given input nums, and lastly we are going to be passing in the new array used array that we have created. Now first we are going to be checking for the base case that if the current size is equal to the length of the original given array, then we are going to add the results of the current array list inside the new instance of a new array list, and we are going to be doing a simple return. If that is not the case, then we have our for loop that we need to iterate over. So very first thing we are doing is that we are starting from the 0 and iterating I until we reach to the end of the array. Then we are first of all checking that if the given I value is not used, then we are going to be adding that value inside the current path that we are iterating over. So we added that. Then we are going to be marking that particular element as true inside our used array. And after that, we are going to be calling our backtrack method recursively, where once again, we are simply providing the results that we have calculated so far, the current path, which now contains a newly added element, and the nums input, and the used array that now contains that the current element is being used. And that's it. Basically, this should ensure that all the work gets through, and the moment the list size is correct, then we would start adding those values inside the result. But the thing is, after the backtrack call, we will also have to remove the lastly used elements. So we are going to be doing that, and we are also going to be removing that value, the very last value that we had in our current list. So we are always updating that in order to calculate new possibilities. And this is the whole solution. Now I know it's hard to visualize, but coding is very small, and also you can understand that how to generate it on a pen and paper. So you can just work around with different examples and it would make sense to you. Now let me quickly run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs super fast compared to all the other solutions, which means this is an excellent approach. Now I know using an extra used array might hamper with our space complexity, but this is still a much faster result. So now I will be posting the solution in our GitHub repository, so you can check it out from there. Thank you.